So here's an example. So I want you guys to pause the video if you haven't done so already. Pause the video, fill out these ratios, and answer the question, does this land on the unit circle? Okay, so the ratios for these here, let's see, sine again is y over r. Well, the problem is I don't know what the r value is. So by solving for the r value, I'm actually going to solve this question down here first. Is this on the unit circle? Does this have a radius of 1? So let's just double check it. I already know for sure that it doesn't because I type this in here. 4 plus 9. You get 13 is equal to r squared because that's x squared plus y squared is equal to r squared there. And then we're going to take the square root. And the r value, the radius of the circle, is always going to be a positive number. So I'm not going to do plus or minus. I'm just going to do the square root of 13. Now, the square root of 13 is not a nice number. Just going to leave it that way. So now we know what this is here. Cool. So let's plug that in. So this is going to be my sine values. And theta is my standard position. It's not my reference angle. It's a standard position angle. So it has to include the sines of the sides as well. So my y value is positive. So this is going to be y over r, which is 13. I'm just going to write that over here, actually. Cos is going to be x over r. So x is negative 2 over 13. I'm not going to rationalize those. You don't have to. And this is going to be y over x, and y being 3, and x being negative 2. So this would be negative 3 over 2. Now these are the reciprocals, so they're just going to take the reciprocal of each one of those. Now the reciprocals of these don't change. They're not negative reciprocals. They're just the reciprocals. So they're just going to flip over. So the sign stays the same. If sine is positive, cosine is positive. If cosine is negative, cosecant, sorry. If cosine is negative, secant is negative. If tan is negative, cotangent is also negative. So the sign still stays the same. It just flips over. That's all it really does. Okay, so this is not equal to 1, first of all. So this is on the unit circle? No. Not on the, oh man, that's bad writing. The unit circle. Keyword, not on the unit circle. Okay. Now, I want to recall later on, like, the reference angle here, like, theta is usually our standard position angle. Our reference angle is this angle that's always measured to the nearest x-axis. That's something that I may have to recall for the next couple slides here, the next couple of pages. Kind of disappears on me there. So we'll talk about this reference angle down here later on. Oh, this page too. For these ones here, just to recall a little information, just a review, refresh. Can you determine what's the reference angle for these, and what is one positive, one negative coterminal angle for each of these? Give me a little time to do that by pausing this video. Okay, so hopefully you tried that out. So we're going to draw and sketch it. So just a sketch. I'm not too concerned about how accurate this is, but I know it's going to be in this quadrant. Okay, so that's 150. Now the reference angle would be right there, so that's going to be the reference angle. So remember that those two are going to add up to 180. So that means my reference angle is going to be 30 degrees, which is 180 minus 150. Okay. Coterminal angles. Let's call it theta CO. Remember to find those, you just plus or minus 360. So these are pretty fast. So 510. And I'm going to subtract 360. Negative 210. Okay, so 7 pi over 4 is 315 degrees. So you notice I just changed that quickly into degrees so I know where to plot it. So that's where this is. But what I'm going to write here is I'm not going to write 315. I'm going to write 7 pi over 4. So if you have radians, answer in radians. If you have degrees, answer in degrees. So my reference angle here is going to be here. Now that's going to be 45 degrees, but you can also think of this as, to find that out, whole circle is 2 pi or 360. Right, so this is going to be 2 pi, right, all the way around. So it starts off 0, goes to 2 pi. And then I'm going to subtract out this other piece that's on the outside edge. So this piece here, I'm going to subtract out. That goes all around this other side. So I'm going to go to find this reference angle. I'm going to go 2 pi minus 7 pi over 4, which is 2 minus 7 over 4, which is a quarter. So this ends up being a quarter pi. Now again, always a positive number. Coterminals, add or subtract 2 pi to the 7 pi over 4, so 7 pi over 4. One's going to be negative pi over 4, which is nice. And the other, 7 over 4 plus 2, the math interpreter, to 15 pi over 4. You notice I'm keeping those in exact values because this is an exact value, so let's leave these as exact values too. 4 pi over 3, sorry. It's 240 degrees, so that's in this quadrant right here. Probably draw more the 60 degree way. There's my picture. Yeah, I'm just going to rewrite that. 4 pi over 3. Okay, so we know our standard position angle. Our reference angle is going to be this angle right in there. So that's my reference angle to the nearest x-axis, like this one here is to the nearest x-axis. So that's my reference angle. Now to find that reference angle out, I'm going to go 4 pi over 3. I'm going to minus the top part of that whole circle. Just get that what's left over. So I'm going to minus 1 pi from the circle. And this is pi over here. That's 0. And then this is like pi over 2 from the top there. So 3 over 4 minus 1 gives me 1/3. So this is going to be 1 pi over 3. Coterminal angles is going to subtract and add 2 pi to each one of these. So if I add 2 pi, I get 10 pi over 3. 10 pi, that sounds cool. And if I subtract 2, I get negative 2/3, negative 2 pi over 3. Cool. Awesome. 70 degrees, so this is nice because they just give us it in degrees, so I don't have to worry about trying to find that out. So 70 degrees. Looks right about there. Now, to the nearest x-axis would be this line. So this would also be my reference angle. So my theta ref down here would be 70 degrees. Coterminal, plus 360, minus 360, so I get 430 and 290. Now these are just the closest positive and negative coterminal angles. They don't have to be the closest ones. 5.2 rads. So what I'm going to do here is I'm going to times it by 180, divide it by pi, change this into degrees. It ends up being about 300 degrees is 297-ish. So it's somewhere in here. Okay. Now the way to do that, remember that's just slightly, oh, this would be 5.2, I should put it there. To change that rads into degrees, remember you have to, I could set up the ratio here. I'll put a question mark there. Over here I have pi 180. I just do a cross multiply and divide in this situation. It's kind of weird to cross multiply, so you cross multiply, divide up. That's why I like to sometimes write it with the question mark on the top. So it looks like that. So you cross multiply, divide. Okay? Now you actually are going to divide by pi in this one. The previous ones you didn't have to divide by pi. You kind of just ignored it and then put it back in there. But you divide by pi because the 5.2 doesn't have a pi in it. Okay, so we know what this is now. This here, very similar to question, the one right above it. We have this kind of angle that goes all around here. We're trying to find out this reference angle. So the reference angle is going to be the same mass. It's going to be 2 pi minus this 5.2 rads. So you're actually going to have to go 2 pi, which is like 6.28, minus the 5.2. So you're going to leave this in approximate answers here. So approximately 1.1. There's only one decimal place here, so I'm just going to leave it as one decimal place over here too. Coterminal angles, you're going to add or subtract 2 pi. So you're going to go plus 2 pi. So one coterminal angle would be, 2 pi, so that'd be 5.2 plus 2 pi. So one's going to be 11.5, and the other is going to be negative 1.1. I'll put down rads here. And remember, if you don't put the rads, I assume it to be rads. If there's a pi in it, like those 4 pi over 3 and the 7 pi over 4, then those are rads. Like you never have pi in degrees. Okay. All right, so this page is just a kind of a refresher. At least the first 2 points are a good refresher. What's the reference angle? How does it relate to this? This is kind of messed up over here. This should be a half. I don't know what that looked like, a root 2 over 3 there. Just a little refresher. Like if you have the same reference angle, you have the same ratio, right? But you may not have the same sign. You notice that all 3 of these, well, actually all 4 of these, 30, 150, 210, and 330, they all have the same reference angle. The reference angle is 30 degrees. So they all have very similar ratios, but some are negative, some are positive because of which quadrant it lands in, right? Same thing with these guys here. They all have the same reference angle of 30 degrees. You notice that they all have very similar ratios over on the other side here, but some are positive and some are negative because of which quadrants they land in as well. You notice that some of them are the same, like 210, but this is 210, 330, but this is 210, 150. So those ones match up because the cast rule says that. Now we can also apply special triangles to these as well, to these points. I already talked about this one here where my radius is equal to 1. It's way up here somewhere. Where did I write it? I wrote it somewhere. Where did I write that one? Right here. My radius is 1 in these formulas here. Then sine theta is equal to y and cos theta is equal to x. Come on. Up back up. There you go. So that's what that's saying there. These are the formulas here. So cos theta is equal to x, sine theta is equal to y. So that means a point xy on the unit circle has to be the unit circle. On the unit circle. A point that's xy up here is just the same as saying cos theta, sine theta. Okay? Now, you can also find these kind of things, these approximations in your calculators too. Now, if they're not on the unit circle, I don't expect exact answers for the ratios. So like 25 is not one of our numbers that are on the unit circle, like 35, 60, 90, etc. So just punch in your calculator, making sure that you're in the right mode. So all I'm going to do here is I'm just going to have an approximate answer. It doesn't specify, 4 decimal places at the top there. So you just punch in your calculator and you get the approximate answer. So like cos 375. Cos 375.9659, okay. For these other ones though, it get a little bit trickier. Like you notice that this is pi over 6. There's no degree symbols for the next 3, like 3, 4, and 5. There's no degree sign for any of those. So if there's no degree sign for them, you have to assume that they're radians. So you either change the radians into degrees by using a little ratio or whatever rule you want to use for those, or change the mode in your calculator. So you hit mode, go to radians, and now if you go tan negative pi over 6, you should get negative 0.5754. Okay, so you just have to make sure you're in the right mode. The next two, like 4 and 5, they're both radians here because there's no degree symbol, but they're different ratios. So you have to know what the ratio is because there's no cosecant button on your calculator, there's no secant button on your calculator, no cotangent button. So you have to look at the identity sheet there and realize that this is cosecant, so this is sine 1.57. Now I can type that in my calculator, 1 over sine 1.57. You notice that the angle didn't change. Still 1.57, stays 1.57. So this is approximately 1.00, how many decimals? 00. So we're really close to being 1. That was probably a couple of reasons for that. It's really close to being 90 degrees. Close, but not quite. Okay. Sine 90 is 1, or sine 90, like really close to being 1. So 1 over 1 is 1. So secant here is the same as cosine, but you notice that this stays negative pi over 6. That didn't change. It's very key. That doesn't flip over. The only thing that flips over is the operation. So it's going to be 1 over, making sure you're in the right mode. So this is going to be in radians because this is, it says radians there. It's in pi. Negative pi over 6. So I get 1.1547. Cool. Now this one here is a bit tricky. So what I'm going to do here is I'm going to write it over. So cotangent is 1 over tan 270. So I'm going to put my calculator back into degree mode. Used to be a point where on a diploma exam, people would have two calculators. On the top say degree, one say radians, so they don't have to flip between the modes. They just flip between calculators. If you have two calculators, that is. The problem is tan 270 is undefined. Now the reason tan 270 is undefined, let's just draw that out. Remember, tan is y over x. It's the opposite over the adjacent, but tan 270. So 270 is right down here. That's 270, straight down. So this is going to be y, which should be negative, or sorry, 0, negative 1. So that's what that is. So if I were to do the math on the bottom here, so let's put the numbers into the calculator, or into this thing. I don't know why this is not working right now. There you go. If I were to put this in here, y being negative 1 over 0, your calculator is going to try to do this math first. It's going to try to do negative 1 over 0, and that's why you get it undefined, because you can't divide by 0. But what you should do, because you divide by a fraction, it's got to flip over. So you're going to take the reciprocal, and that's going to become 0 over 1. Well, now we don't have a divide by 0 error. We have a 0 times 1 divided by negative 1 ends up being 0. So that's the correct answer. You can look it up and say, what's the cotangent of 270 on Google? They go through the same explanation. Some people use the word infinite. Now it's not infinite. It's undefined. Infinite is not a number. You can't use that in math. It's just nothing you can't really use. You can't use infinites in math. You can use undefined apparently, but 1 over 0 flips over to be 0 over 1, and you get 0. So even if I could try my calculator. It depends on the style of the calculator. If you have some newer calculators, you could try to do this. But 1 over tan 270, the calculator just spits out a domain error. It's undefined, doesn't work very well for us. If you have a cotangent button, it does work. You can go cotangent 270.